All right. Good morning. Happy Monday, everybody. Excuse me. We're back here with Advent of Code Day 5. At a glance, it looks like a Towers of Hanoi problem, but I don't know. I haven't read it. Got my coffee. Got some water, staying hydrated. All right, let's seeing myself in the little monitor. Probably not good for my mental image. Let's dive in here. We're gonna see if we can't get a solution in C#. I've created a C# project here. Not sure if I'm gonna do F# today. Let me change the name of my stream. Hang on. Coding Day 5 in C#. Maybe some Unity after. Got to update that. Bear with me. Why can't I find... Oh my goodness. There we go. Stream title updated. Otherwise people come in my stream and yell at me. I don't like to be yelled at. I like to be criticized, but yelled at, no. Okay, here we go. Excuse me with all my throat clearing. It's still early for me. It's the first. You guys always hear me when I first start talking for the day, and my vocal cords haven't warmed up yet. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be arranged. All right, I gotta move some things around. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure. Okay, so we're gonna get this input. Parsing this is gonna be annoying, I think. Maybe not. I don't like that it doesn't start off by saying how many. It would be really nice if it told us how many rows and how many columns we needed to parse in at the beginning, but it doesn't, and that's okay. We'll have to make do. In this example, Saddle Ray, thank you for the follow. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Z is on the bottom and N is on the top. Stack 2 contains 3 crates. From top to bottom, MCD, and finally stack 3 contains a P. So we got to read this in, and then we follow these instructions, moving them around. It looks like move 1 from 2 to 3, move 3 from 1 to 3. So we'll be moving them around in such a manner. Then the rearrangement procedure is given in the steps of the procedure. The first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1. So top D gets moved there, resulting in this configuration. Okay. In the second step, 3 crates are moved from stack 1 to stack 3. 3 crates move 3 from stack 1 to 3. So that would mean D and Z. All right, so we're doing it stack wise. You push and pop these bad boys. Then both crates are moved from stack 2 to stack 1. And then finally, you need to know which crates will end up at the top of each stack in this example, the crates are CMZ. So this problem statement makes me assume what's interesting about these is they don't have any weird edge cases where if there's nothing in the stack, what do you show? So for example, if these all ended up on the top of 3, should we just show, see if this was CMZ from the top, would it just be C? But I think it's set up so that you're essentially always guaranteed to have something in the top. All right, let's see if we can parse. Oh, parse it in. Let's see, could I do something smart here? If I were in Haskell, I would write a parser combinator, I think. Maybe, I don't know, can I do something with regular expression? Sample.txt. I always call it sample. I should probably be calling these example. That's okay though. All right, so I'm eventually going to want, I know these are stacks, but I don't know what the next part is gonna be. So let's be a little bit versatile for the next part. Moving things around, and probably want to just use like in a list, the list type, although that's probably an array list and it's gonna be slowish. But that's okay. We'll use a list to represent this data, a list of characters, and then we just need a way to move some chunks to others. Stack might just be the nice way to do it though. Is there a built-in stack? Stack. Ooh, there is. Yeah, I guess we'll just use the stack data type. We'll use the stack data type here for these. So we're going to have a list of stacks to represent our piles. So I'm gonna make a class called supply stack. So I want to be able to, and it's really it. I don't know if I actually need this. I don't know if I need a supply stack. I don't think I do. Like, part of me thinks I should over-engineer it, but I don't think I need a supply stack. Instead, I'm just gonna have a list of stack of chars like this, stacks, and then. I hate that autocomplete. VS Code, get with the program, man. All right, now I need to be able to parse in each row of this and load up characters onto each stack. Let me look at my puzzle input, see. Does it tell me how wide? I know mine is gonna be 9 wide. I don't know if that is gonna be the case in general. But maybe I cheat and just do mine, make mine 9 wide. Cheats. I think we cheats. I like it. All right, we're gonna cheat. We know ours is 9 wide. I don't know if we're guaranteed to be 9 wide. Does the word 9 show up in here? No. we're gonna cheat. Well, no, I gotta be able to work on the sample too, so we're not gonna cheat. Hang on, here we go. Let's read this input in. So, input string array rows equals file.readAllLines sample.txt. Okay, so we got our sample.txt. We read until we get a line that has a bunch. So we need to detect. Let's do console.writeLine rows 0. Let's just have a peek here. Console.writeLine rows 0 dot length. How long is this? Is it going to include all this white space? Yeah, it has the white space in there. Look how nice they were to leave us that white space so we don't have to go through and figure it out ahead of time. .NET run. Honestly, I could probably do this with some kind of regular expression, but we're gonna be lazy here. Yeah, this tells us how many columns we have. All right. So let's do that. Let's do that. We're gonna figure out how many columns we need. What would that be? 12 divided, or 11. So it's gonna be that plus 1 divided by 4, I think. So if I had, let's make a second sample input. So if I had one more, let's see, sample 2. Find another one. Let's add in another, so it's 1, 2, 3, space, 1, 2, 3, space, 1, 2, 3. No space on the last one. Yeah, so plus 1. So if I had one more, let's add in another one. G4. If I had that, I'd come here. Yeah. There we go. Let's see what sample 2 looks like. I'm just letting my brain get warmed up here. Wake up and code. That's what we're doing. There we go. Yeah, plus 1 divided by 4. All right, so we're gonna say, so we need to loop through until we get to a line that has like the 1, 2, 3, 4 on it. So we're gonna write a function called get stacks, I guess. List stack char parse stacks. This is gonna take in a string array rows, and it sort of is gonna start at the top, and we're gonna say int stack count is equal to rows of 0.length plus 1 divided by 4. So that's how many stacks we're gonna have. And I'm actually gonna, can I do this in C#? This is an interesting, can I have an array of stacks of characters? Even better, I can. And then we're gonna create our stack char array equals new stack char array of stack count. So that now we're gonna have that many, an array with that many slots in there. Stacks. We'll return stacks at the end. And then we gotta initialize all those for each stack. I can't do it, so I'm gonna have to do for int I equals 0, I less than stacks.length, stacks plus plus stacks at I equals new stack of char. All right. Oh, I plus plus, thank you, compiler. So we're gonna initialize that. All right, now we can actually read through our lines. So yeah, we chunk it up into chunks there until we get to a line that sort of looks like 1. So space 1 followed by spaces. So how many spaces are in between 1? How many spaces are between these? 1, 2, 3. 1, 2, 3 spaces. So I am going to make a predicate bool is stack row, and it's going to take in a string of row, and I'm going to determine int calls like this. Oh, really I can say if my row contains like a square bracket, then I know it is. All right, so is stack row is gonna go to, so this is a little thing I can do where I gonna check if my row contains one of these. We're not doing anything clever here. All right, and then we're just gonna say for int I equals 0, I is less than, and our condition is stack row of I plus plus, right? This should be, or even better, for, we're starting at the top coming down though. Maybe I should just make these lists instead of stacks. I thought I was gonna be clever here. Let's make these lists. Let's make these lists just to make our life a little bit easier. I'm gonna regret this later, aren't I? Okay. Is stack row, because now I want to do for each string row in rows like this, and then I'm gonna say if it is not is stack row. This is the one time I'm like kind of okay doing it on the line list. All right, so if it is not if it is not a stack row, we're done. We break and we're done. So as soon as we get to a row that has no stacks in it, we're done here. Console.writeLine row. Let's just check out, see if our program should print out parse stacks rows. Do a quick test here. Yeah. Beautiful. We got it. I'm not sure what this extra. Oh, it's because it did go to a next line here. Okay. So where we're going through there, break this up a little bit more. Lists, char array, init stacks, int count, and we're gonna put this here and return stacks, and stack count still gets determined here, and this just becomes count. Just cleaning it up a little bit, and so then we get stacks. Managing complexity as a programmer, your goal, this is what I always tell my student, your goal should be to figure out how to manage the complexity, so that way when you look at your code, you can read it and understand it and work through it. And if I were to come over and look at your program, I shouldn't have to strain my brain too much to try and understand what you're doing. So in this case, we're gonna init stacks, figure out how many stacks are, then we initialize the stacks. All right, now we're gonna parse each row. So I'm gonna write a method here, parse stack row, like this, and it's gonna just take in a row and my list of stacks, my array of stacks like this. So now parse stack row takes in my row, and then I get my stacks like that. And I think maybe I can get the length of it here actually. All right, so now I want to come out and basically check whether or not there's something in each of those sections of the code. So I'm gonna do for int I equals 0, I is less than stacks.length, I plus plus. So we're gonna say for every stack, is there a something that I need to add to this? So in my picture, my idea here is I'm gonna examine those, essentially, I don't even need to examine those 3 characters. I just need to examine this 1 character. So I'm going to examine this 1 character. If there is a character there, I'm going to go ahead and add it into that stack. So there's a translation I need to make for each stack. So int ch index is going to be I plus 1. So it's I times, actually, I times 3 plus 1. Rit, happy Monday, my friend. So nice to see you this morning. So I'm pretty sure I'm going to do my index times 3 because I need to shift over by 3. So it would be from here I go 1, 2, 3 plus 1. We're going to try that. 3 times 4. No, times 4 plus 1. I got it right this time. So I times 4 plus 1. I think that's going to give us our character, the index of our character, and then we're going to say if row at that character index is blank, we're just going to continue. We're going to skip that character. Otherwise, we're going to print it out. So just for now, we're going to print it out like this. I'm going to do char ch equals row chix. And we're just going to do this to see if we get all of them out. So we should get DNCZMPG. So just right across the top there. DNCZMPG. ZMPG. All right. So now we're pulling those out. If we've made it past this continue here, this means that we have oh, this one. So yeah, this one's, the parsing on this I think is actually pretty challenging. I haven't gotten to part 2. I'm still in part 1. I think, again, a lot of these problems, again, I don't know why I say again, I haven't said it yet. In my opinion, most of these puzzles, at least the first parts aren't that hard as long as you have a good approach. It's coming up with the approach that's the challenging part. And in this one, the parsing I think is a little tricky. I could do something clever like using a regular expression, but I'm going to go through. I'm going to be doing this with my students. So I want to come up with a straightforward approach that doesn't require you to have some kind of fancy parsing library or a regular expression. So this is allowing me to extract each of my characters. And then if I made it to this line, so maybe I should say if it's not this, do a thing. Yeah, I'm going to do if it's not that, do a thing. And the continue there might confuse some of my students. But if it's not blank, that means we have a character. That means there's something in that column. And we're just going to do stacks at I dot add ch. So we're just going to add that into our stack, and it's adding them top to bottom. So this will parse our stack rows. And then let's for now, we've parsed our stacks like this. Oh, yeah, I mean, if you don't have to watch me do it, but I'd love it if you did. I'd love it if you stayed and watched. Are you doing yours in C#, Rit? Stacks. It's not cheating if you watch someone do it in a different language. Oh, how about this? You can do it with me. You're doing it. You're not cheating. You're doing it with me. Let's print out each one of our stacks here. List, just to give myself confidence that they're all in there. List of stacks. Stack in stacks. I don't think there's a nice print string. It's not a nice toString on these, no. So I think I have to do dot, is there a dot join? Yeah. Join with comma. Is that not how join? Or is it string dot join? string.join. There we go. Separate them by spaces just to give ourselves confidence that we've pulled them out here. All right, NZ DCM PG NZ DC M P. Oh, and then I have this extra one with a G. Okay. So let's switch back to sample. Okay. All right. So I've parsed in. That was the hard part. I have parsed in my rows here, and now I need to parse in my instructions. And just process. At this point, it's just a processing game. The things I need to do is I basically need to be able to say, move 1 from 2 to 1, move 3 from 1 to 3. I need to be able to move from one stack to another. Okay, so not too bad. Let's write that. This gave me confidence that my parse was working. So now I just sort of need these void move int from, int to, and int amount. All right, what's the order? 1 from, all right, so I'm gonna read this, I'm gonna parse, I'm gonna have, can't talk. Int amount, int from 2, and I'm gonna do this recursively because I'm a functional nerd. We also need to have our stack array put in here, so we can actually pull things down. So what I'm gonna do, I'm gonna say if amount is less than or equal to 0, we're done. We're done. Return. Otherwise, we're gonna go ahead and move. We're gonna take the first thing off of the stack. So char to move equals stacks at from dot remove 0. Does this return? Oh, remove. Is there a remove at 0? Cool. And if you know, I appreciate you hanging out. You don't have to hang out. But yeah, definitely gonna have a little bit of spoilers here. All right, so I was wishing this would pop off. This is where stack would be slightly better. This is gonna be slow too, because this is an array. So when I remove the first thing, it like crunches everything over, but we can be a little bit lazy. I peeked ahead. Our input is small enough that it won't matter. Here we go. So we're removing at 0, but that we have to get it first. So it's gonna be stacks from index 0 is what we're gonna move. Then we remove it, and then we just add it. We have to add it at the beginning of the other stack. So stacks to dot insert to move. And this is gonna tell us we have to pass in a starting index. Yeah, I hate this. This is where a stack would be better. As it turns out, insertions at index 0 are really, really low performance. Like about as bad as you can get performance-wise on stacks. But that's okay. That's okay. So here we go. Let's keep going. So I have my move here, so I'll be able to move between the two. Now I just need to parse in my instructions. So I need to get past my stack. So I'm looking for a blank line. Can I do, yeah, so we're gonna go down to parse. We're gonna write a function, parse instructions. What's the structure I want to use here? Void parse instructions. I kind of want to just get, let's get a list of strings here. Parse instructions, and it's going to take in all of our rows. Okay. Create a new list, string instructions equals new. We'll return our instructions here in a second. And then we're gonna loop through our rows. For each string row in rows. And we know we're an instruction if we have the word move at the beginning. All right, so we're gonna say if row dot contains move. If it doesn't contain, I'll just do if it does. Try not to confuse anyone. I was gonna say if it doesn't, just go to the next thing. But if it contains move, we're gonna keep that line. So our instructions dot add row. So we parse out our instructions. If it contains the word move, we keep it. We keep it. All right. So we have our stacks, list, string, and maybe what I really want to do, because I need to split this. This is where the regular expression would be nice. I should look up, well, I'm trying to keep it simple. I'm trying to keep it simple. Yeah, so it's move, followed by an integer, followed by from, followed by an integer, to, followed by an integer. All right, here's what I'm gonna do. Here's what I'm gonna do. I actually want my instructions to be a triple int. All right, and it's gonna be amount from to, like this. Really? Maybe the second part's super hard. We'll see what the second part says, because I'm feeling like I'm just about done here with the first part. Again, like I said, the hardest part on this puzzle seems to be figuring out how to parse it, reading your input into something you can use. But maybe I should try and be a little bit more. Well, yes, this is the hardest. Let me put it. This is the hardest puzzle so far. This is the hardest puzzle so far. I would agree with that. But I feel like I'm almost done here. It's all about, again, having a solid strategy to approach these, I think is good. So sample, parse. Yeah, I want to pull out each one. So I'm going to do something dumb. Row dot replace. I'm going to replace the word move with a blank. I'm going to replace the word row equals. Can I reassign row like that? No, string. Call it ints because I'm bad. Replace remove. Yeah, that's what, Keith. That's how I'm feeling. I feel like it's tricky to parse. Honestly, the only reason I'm parsing it this way is because, and I could use a regular expression here. Hang on. Can this use a regular? Can replace use a regular expression? It can't. Console.writeLine inst. I'm doing something kind of dumb here to get rid of these. We're gonna parse this in. Instructions equals parse instructions rows. Okay, I just want to see here. Yeah, so I think it's just tricky to pull out each one. I think it's tricky to parse. I should really be using a regular expression. So you could do a match. So this is what I was saying. I wish I had a parser. I wish I knew how to do parsing in C# a little bit better, because you could write a thing that says, oh, go ahead and just find, like, for every line, find find this pattern, square brackets with a character inside. And when you find that, match it and pull it out. I know, that's how I feel. I feel like, well, also I'm trying to keep it simple enough for my students to be able to do. I'm coming up with a strategy that I can explain to my students. And this is good. This is really good for loop practice on this one. So, and then we'll trim this. All right, and now I should be able to just read these straight through. So let's try it. Let's try it. We're gonna do our inst here. Now we can split. So this will be a string array. Dot split. What does that look like? String dot join. All right, I have some extra things in there which I don't like. Let's do one more replace on this. Replace double spaces. And I bet there's like a double space, a single space. There we go. So now I have these into each string. Yeah, I could do this using some higher order functions to iterate over stuff. Okay, here we go. We have this, so now we just gotta parse it. So inst dot select int dot parse. So we're gonna parse them into integers, and then to array. So int inputs like this, and then I'm just gonna do instructions dot add inputs 0. Hang on. Inputs 0, inputs 1, inputs 2. So this one is just a parsing challenge in many ways. All right. So I think, let's run this. Yeah, you could do this. You could really do some nice functional programming on this one. I'm not doing the functional. I'm doing very iterative here. Like I said, I'm trying to come up with a strategy that my young students are going to be able to use. So I got my instructions, and now that I have it all, I just do for each int a, int f, int t instruction. I'm going to call inst in instructions. We just loop through them all. And we're going to do move inst dot a, inst dot f, inst dot t, and the actual stacks here like that. All right, so this should make sure my program doesn't crash. It does crash, which is a little bit because I didn't actually do this here. I was gonna do this recursively. So amount -1 from 2 stacks. Look how stupid I am. There we go. Still have an issue. So I can do this as a loop though. For int I or while amount minus greater than 0. What am I doing wrong here? I do have a bug on line 7. That's interesting. All right, we'll have this when we call move. I'm gonna have it print out console.writeLine move amount from to. What am I doing wrong here? Move 1 to 2. All right, let's look at this. Move 1 from 2 to 1. Move 3 from 1 to 3. All right, so this should console. Let's see, and it's dying. It's saying on line 7. Oh, line 32. Because I gotta subtract 1 from this. Okay, so in my inputs, actually, my from and to's need to have -1 for my indexing. There we go. Aha. Okay. SMAB UK has a much simplified version. Indexing by, so here, you want to hear something crazy? So I teach AP computer science. I teach computer. There's 2 AP high school AP classes: computer science A and computer science principles. Computer science A is a Java programming class. This would be like your typical introduction to programming in college, in undergrad. That one's in Java, it's fine. And then you have computer science principles, and this one is like a very abstract course. It's kind of CS50-ish, but on the exam, they use one index by 1, where 1 is your first index. It drives me nuts that, which is fine. It just drives me nuts that they that the 2 exams are so different. It's very confusing to students. I use C# in my principles class. Okay, and now I just need to print out my stacks, or the first in each one. So now I should do stacks.select. S goes to S. Take the topmost element, I believe. Can I just do? This is a very console.write. This is the non. This is not functional, right? Oh, because this is going to be void. All right. Can I do for each here? Oh, I really wanted to do that. I can't put that in there because it's a void. So this will get me the first thing of each one. For each char in this. Ooh, hang on. String.join. No spaces. There we go. Console.writeLine. CMZ, that's what we were hoping for. All right, let's download this. Let's get this input. Input.txt. And hope for the best. This one, I bet there's gonna be some fun visualizations. Hunsmutical Q. Okay, let's try it. Hey, we got a gold star. That's what I like. I should start, with my really, really young students, I would give them gold stars, but I should start giving gold stars to my high school students. Do you think they would like that? All right, there's part 1. Let's do a commit here just so I have it. Yeah, I think you could do a really, really fun visualization with this. I'm tempted, I won't have enough time for this. I'm tempted to write a Unity program where you have like a crane actually like moving things around. That would be fun. Make sure I didn't get anything awkward. Git commit -m feat completed part 1 day 5 part 1. Yeah, so my guide for this one will be, oh, I'm sure someone will. That's another reason. Someone animated the rucksack one. I saw this really great animation. It wasn't, I didn't see it on the subreddit, but I saw it on Twitter, of these backpacks full of cubes, find, you know, they're spilling out of the backpack and they're finding the right cube, and then they put all the things back in. It was cool. I liked it. Yeah, so I've been doing these guides on my YouTube channel. I have like these step-by-step guides to these. So I'm calling them beginner's guide. So guide for how to approach these, that I sort of break it down, like here's the functions you should try and write, here's the method you should try to write, and then I try my best not to give spoilers on these videos, but this is another one that we can do. This one, this whole puzzle essentially is parsing. I think that's the hard part. This feels straightforward and easy to me. Although if you're using a language that doesn't support dynamic arrays or stacks, you'd have to implement your own array stack thing. All right, let's look at part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Interesting. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. You could have split the instruction in space. Yeah, I could have. Yeah, you're correct. Ooh, that's so much smarter. Smab UK, that's so much smarter than removing those words. I should have just done a split and then pulled out those specific chunks. I'm a fool. See, it's one of the fun things about programming is this is something a lot of people don't realize, I think, when they're starting out, is there is a lot of room for what I would call creativity in programming. Gotcha, Keith. Yeah. So I always like to try and I try and do project-based learning in my classes. And because you can't cheat on a project that is open-ended. And so I tend to do projects that are like, you have to do usually one of the first ones I do is sort of a text adventure. All right, sorry, I gotta focus. The Crate Mover 9001 is notable for many new and exciting features. Air conditioning, leather seats and an extra cup holder, and the ability to pick up and move multiple crates at once. Okay, so now this is interesting. So we need to be able to chunk several indexes, pull out several characters, and put them into a spot. Consider the above example. Okay, I think I'm getting it. The action 3 crates in 1 sec doesn't change the order. All right, so we have a claw. That's fancy. And we'll move groups of them at the same time. All right, so if someone, I didn't fully read this thing, but if someone notices that I have misread it, please yell at me here in a moment. So the move needs to sort of be different for this one. So I'm gonna rename this to move part 1. The only thing that needs to change is move between these two. And we've got move part 2. All right, so instead of pulling them off one at a time, we're just gonna get a subarray and move that whole subarray onto the front there. Can I get subarrays here? All right, I can't get subarrays, but I think I can turn this into a string. All right, so we're gonna I should have just made these strings and then just chopped us like string builders. That would have worked well. All right, we're gonna be a little hacky here. We're string.join. Or all right. I'm not gonna do the hacky thing. Let's see. Can I do a subarrays and see C# sub array? Get a subarray. Array.copy. Okay. Some people actually solved part 2 as part 1, found it was wrong, rewrote it, and then they found they needed it again. That's like, I wonder if that was intentional. That feels almost intentional. What a great troll that would be if that were intentional. All right, so we are going to do that. That cracks me up. We're gonna get our subarray. Stacks dot. Oh, it's a list though. So it's a list. What am I doing here? Okay, all right. Here's what we do. We're gonna have a list char to move equals new, like this. And each time we remove one, all right, here we go. This is what we do. To move dot add to move. Okay, I've done something terrible here. I'm gonna call it chunk. All right, so we're gonna just pull them off, add them to this list. This is a little bit lazy. I could do a subarray thing a little bit better. And then we need to put them on essentially in the reverse insert at 0, kind of in the reverse order. So we'll do while chunk dot it empty. Is there count? I guess there's not an is empty. Count greater than 0. This is bad. This is hacky here. I'm just doing it to get it done. This is hacky here. Char to move is, oh, is there, oh, I like that. Dot any. Like this tells me, oh, Keith, my friend, my mentor. Thank you. We're gonna pull out from our chunk dot remove last. Remove at, oh, this doesn't return anything. I'm feeling bad at programming right now. Chunk.get chunk.count -1. This is like the hackiest. This is gross. No, please do not write this program. This program is the worst. This is bad. Is there a last? I tried dot last. Chunk dot last. Oh, it's part of link. Chunk dot last. Does last? So here's what I worry about. Since I'm already doing it terribly. We're gonna do this. I was gonna say, well, I feel like last, does that iterate through the whole thing and pull it off at the end? I hope not, but I suspect it might. So the reason I need to iterate over a chunk is because it's in the reverse order, so I need to pull the last thing out first. Oh, so you're saying why don't I do like an iterator for int I equals chunk dot length, chunk dot count -1, I greater than equal to 0, I minus. This is what you're suggesting? That's probably a better idea. And then this just becomes chunk of I. Oh, but then I'm really bad. Chunk.reverse. All right, we'll do it. Chunk.reverse. Does this return a new list or does it actually reverse it? Actually reverse it for each character. CH in chunk. Stacks. Oh my goodness. Look, you guys, you're helping me. Oh, please, please. Please work. All right, we get a second gold star. 2 gold stars for the day. Thank you. Thank you for that. I appreciate it. Keith, let's check it out. Day 5, record instruction from 2 count. That's probably what I should have done. I used a triple. This is better, from 2 count. This is a much better way to do that. I don't even really know why. I guess I kind of do. It may be legacy reasons, but pairs in C#, I overuse them, and I really shouldn't. You really shouldn't use pairs pretty much ever. They're just hard to read. A record is far better. All right, so our solve here. Ooh, I like this. I'm liking this. We're gonna read in our lines, okay? And then our parse stack definitions. We're gonna take, well, it doesn't contain the word move. Okay, so this is interesting because you take them all until you get to move. Yeah, that's the competitive spirit, Smab. I used to, when I was younger, I used to really, Code Chef used to have these where it would try and evaluate how fast your code run in milliseconds. It would run it, I think, like 10 times and then take the average, and that was your like submission speed. And so I used to do it essentially in assembler. I did in C, and then I would optimize in assembler for these crazy programming competitions. Okay, so we're gonna read everything until we get to the first line that says move, and then where L string is not null or white space, then we reverse it. So the first thing, so you're using it stacked. So you take it, so your stacks start from top, so you can actually push them on. I actually started out using a stack and was thinking I would, and then you skip the stack numbering line. So Keith, I thought about this too. So your condition here is similar to mine. I have it, well, what did I do? Is stack row. So my stack row, I just said, well, as long as you contain a square bracket, then you're a stack. Performance and readability. Ooh, that's a high order. That's a high order sometimes. Totally possible. Totally possible. At least you're not code golfing. I'm not a fan of code golf. Let's see here. And then we select our chunk by 4. This is essentially what I did. Get the letter. This is nice. I really like, I love this. This is beautiful. This is Keith's, right? Keith, great job on this. I really like the way you're doing this stack definition. Very clean. I think this is easy to read, and it just sort of makes sense reading top to bottom. This would be very challenging for a beginner to read, but I really like it. I really like your stack definition here. And then we loop through it, and we build a stack from those. This is, the word tasty comes to mind. This is a tasty parse function. I really like it. And then your parse instructions, split, description.split, new. Ooh, I've never seen this. Remove empty entries. I really like this. I've just learned something new about C#. This remove empty entries. Oh, and you're splitting on these things. This is great. I love this. And then we're gonna select int parse, turn it into an array. And then is int array v, and then we turn it into instructions or not. I like that. This is great. I really, really like this. In your instructions, just you parse them in. We have our stack definitions, and we say for every instruction. Range 0 to list for each stacks. We push or pop. I like it. We push or pop, part 1. And then for this one, you take a... this is essentially, again, what I did. There's like this interesting consideration. What if we have these giant stacks or something where we have to... Anyway, this is nice. Keith, great solution. I really, really like it. Nice job. Smab UK, let's check out what you got here. With the what would this be called? What are these called? I can't remember, but nice use of them. I was gonna call them decorator. They're called something else in C#, I believe, but I like that. Ooh, you have like a whole framework set up here. A partial sealed class, day 2 attributes. There we go. C#, they're called something else. What are they called in Java? They're called annotations in Java. Part 1, solution 1, input toString. You have a Blazor front end? Nice. I gotta check. Let's do this here. How do I start this? I'm coming back later to see your whole setup. All right. I've been using Blazor for like 6 months, something like that. I started using it in either January or February of this. Oh, I guess a year now. Holy moly, we're at the end of December. Solution 1. Parse the input into stacks and instructions. This is nice. This is nice and clean. And then for each instruction, we go through and, you know, I made mine. I have like a move method, but yours works nicely here. It says for every instruction, push, pop from one, push it onto another. Nice. And then you get message, which I'm assuming is you print, gives you out the like single line solution. Solution 2, parsing the input, and then for every instruction we do a little bit more work. We pop them all out and then we go in reverse. I guess everyone wanted to do this reverse thing. I wanted to find like a subarray and like chunk subarrays on top. Okay. I like how clean these two solutions are. I really love Keith's use of LINQ here. This is a very .NET-y approach. From what I understand, if you're using the links and stuff, it's a really nice .NET-y approach. And then Smab UK, you have I really like your test harness. I want to look into that more. Really, really short, concise solution. You know, you can read this and like, oh, this is what it's doing. I can imagine what parse input looks like. So let's look at that. Using a record struct for that. Nice. Similar to a triple. Parse input. Twice as slow using LINQ. That's interesting. That's interesting. I imagine it is doing extra iterations or something like that. Because the thing with LINQ, it's sort of like it's O of n for each one of those things, and if you have another n, anyway, I imagine it. Hoping for something chunky tomorrow. Keith, when you say something chunky, you're hoping you're able to use the chunk by method, or hoping for something beefy, like a hard problem. Let's see here. Harder, yeah. I'm looking, you know, I want something that has a little bit of an algorithmic approach to it. So like I said, on my YouTube channel, I've been doing these beginner's guides. I've been doing these beginner guides on my YouTube channel, and so far they've all just been super straightforward. This is the first one I'm going to say, okay, well, here we have this interesting, challenging parsing problem. This is totally a parsing problem. So how do we parse it? How do we break this parsing into steps? The beginner thing, and one of the things I want to do is I'm hoping to be able to talk about, search trees and graphs and stuff like that, and have these beginner guides that sort of introduce my students to the idea of these algorithms outside of the context of, oh, well, we're doing an algorithms class. Instead, say, okay, here's this cool data structure that we can look into and explore. An assembly language, nice. There was on Coding Game, there was, or ICFP here, I probably have it bookmarked. This is one of my favorite programming challenges of all time. What year was this? This was the ICFP 2006. This is from a long time ago. This is one of my favorite programming competitions ever. The premise is you've unearthed these tablets that have like this assembly language printed on them. And they give you these programs to solve. All right, so you have this specification language here for a little machine with the different types of instructions, what you can do. And then people have written these compilers and built these programs. And then inside of this, once you have your machine, inside of this program are a bunch of more programming puzzles. So just to unlock and be able to start getting the puzzles, you have to implement this machine. This is such a cool puzzle. I've used this with my high school students before. My advanced soft. I'm very, very lucky. Sometimes some of my students have been. So I teach like ages 7 through 18. So some of my students who are in high school have essentially have a bachelor's degree worth of knowledge in computer science before they even get to undergrad. Not all of them. Most of them don't, but there's a handful who do. And I like to use this as sort of the final project in sort of what I would call an architecture unit, where we've talked about assembly and how to do this stuff, and then we end up implementing this machine, and students love it. Some students hate it. I love it. Some students hate it. Great solutions here. I know my streaming schedule is a little weird. I have stuff I gotta get done this week. I know my plan was to stream longer. I'm gonna disappoint some people. My scheduled stream wasn't scheduled to start until now, and here I am wrapping up a little bit. Just because I have so much to do today. This is a busy week. December is the end of a semester, and so I always get busy. 2 a.m. where you are, Keith? It is 6 a.m. here, or almost. It's approaching 5 till. I woke up at 4. I don't use an alarm. So the reason I chose 6 is because I know I'll be awake by 6 as my streaming time. Yeah, I have. So I have a class that I have to prep for. I also want to put together a guide here, a beginner's guide for this problem. And I know that's going to take me some time to do. And streaming is just, I love it. It's so much fun chatting, hanging out with other coders, and talking through problems like this, and seeing other people's solutions. Is so much fun for me too. But it's distracting. I don't actually feel, whenever I stream, I don't feel like I actually get anything done. If you go and watch my previous streams, I keep trying to get something done at the end. All right, I got to work on my Unity thing. Next term, I'm teaching a Unity class. I need to put together some projects for my students in my Unity. And I'm like, oh, I'll do it on stream. Does not happen. Does not happen. That said, I feel a little bad about it, but I'm gonna stop early here. I know I haven't gone for 2 hours, just an hour today. Fun little puzzle. Keith, Smab, I think Rit, if you're still here, thank you for hanging out with me this morning. I hope you've enjoyed it. I know I have. Yeah, Smab UK. I need to master the multiform technique. That's the one thing I want to do. Master the multiform technique where I can multiply myself. Each one of my parts can go off and do something, and then come back together and meld all of those experiences into one. Not enough time in the universe, unfortunately. But yeah. If you're new, I don't know if anyone's new watching. I got Saddle, thank you. I know you're secretly watching. Thank you so much for the follow. I will be back almost certainly tomorrow to do day 6 live stream tomorrow morning my time, early my time, when I wake up essentially. So if you're up, come on by, check it out. And as always, thank you for watching. Have a beautiful day. Keep on coding, and I'll see you next time.